Okay, dear students, in this session, we'll learn about the fundamental concepts in organic reaction mechanism. The fundamental concept in organic reaction mechanism, we have to know that how the reaction will occur. Means organic molecule, how they react, which gives a product through intermediate. Okay, so the fundamental concepts in organic reaction mechanism. So how the reaction will take place, and before the forming the product, it occurs or it reaches to intermediate state. It reaches intermediate state. You can notice here. Okay, so organic molecule. If you take any organic molecule in the presence of attacking reagent either an electrophile or a nucleophile. So we'll discuss about what is electrophile and what is nucleophile. In presence of attacking reagent, organic molecule reacts with the attacking reagent, gives a product. So in earlier, we know that reactant react with each other, gives a product, right? This is a normal chemical reaction. But in organic chemistry, organic molecule means substrate. This also we call as substrate. Organic molecule we call as substrate, which is attacked by attacking reagent. In presence of attacking reagent by electrophile or nucleophile, which forms a product. Before the forming of product, there will be an intermediate state in between the reactant and product. Middle state of the reaction is called intermediate. Okay, intermediate is also called as transition. Intermediate is also called as transition state. In intermediate state or transition state, this reactant, half of the reactant is converted to a product, okay, and half of the reactant will be left behind as it is. Or both attacking reagent attacks, and it leads the formation of product will be takes place in between that is an intermediate. With the forming of an intermediate, majorly we'll be getting a product as well as byproduct. Okay, major what we are getting, that is product. Minor what we are getting, that is byproduct. This is the normal reaction, fundamental concepts in the organic mechanism, organic reaction. Reaction and mechanism. If organic reactions or organic mechanism, how we are representing? We use a word of if condition. If we write organic reactions in a stepwise, that is called mechanism. If we write organic reaction in single step, okay, usually we'll say organic reactions, we'll write organic reaction in single step because it's an organic reaction itself. So if we use a word of mechanism, this mechanism represents stepwise explanation of reactant to a product. So in all organic reactions gives a product. Major compound is product, minor is byproduct. So reaction, organic reaction and organic mechanism. So which takes place in several steps, hence it will be represented as mechanism, stepwise explanation. Okay, so how organic reactions gives a product. Substrate or organic molecule reacts in presence of attacking reagent, gives a product through intermediate and forms a product, as well as the unconverted product, means will be getting the major product, the left behind is minor product. That minor product we call as byproduct. Okay, so this is how the reaction, organic reaction will take place. Okay, substrate, attacking reagent, electrophile, E plus, or nucleophile, Nu minus. Okay, I'll tell you what is electrophile and what is nucleophile. Is a product through intermediate. Okay, a major product will be forming, and along with that we'll be getting the minor product is called byproduct. Okay, so this is how the organic reaction will take place. Reaction mechanism. This is reaction mechanism. How this covalent bond will break, reaction mechanism, how mechanism will take place. We said that the intermediate will be forming, transition state will be forming with the formation of the product. How intermediate will take place? The fission of covalent bond is cleaved by two ways. Okay, fission. If we take any organic molecule, organic reaction or molecule, AB is a substrate or organic molecule. In presence of attacking reagent, which should cleave, it should cleave, okay, break this compound. Compound breaks may be equally or unequally. Heterolytic, unequal cleavage. Homolysis, homolytic, equal cleavage. Okay, so reaction mechanism. This reaction means substrate to give a product through intermediate. How this is a product? The fission of covalent bond, because the sharing of electron, covalent bond, in that the fission, separation. This molecule splits into half, 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 that is two or more, that is called fission. Fission of covalent bond, this can be cleaved, can be break by the two ways, either equally or unequally. If it is equally, then it is called homolysis. If it is unequally, then it is called heterolysis. Okay. So reaction mechanism, that is fission of covalent bond. The covalent bond can be cleaved either by heterolysis or by homolysis. Equally they can cleave or unequally they can cleave. Based on the cleave, we separate it as homolysis and heterolysis. Okay, so we'll see what is homolysis and what is heterolysis. First is heterolysis. Name itself indicate heterolysis. Hetero, different, unequal. Okay, lysis, separation. In this heterolytic cleavage, the bond break in such a way that the shared pair of electron is carried away by any one of the substrate. Separate atoms, any of the separate atoms. This leads to the formation of anion and a cation, negative charge as well as positive charge. Okay, I said if the molecule AB, okay, AB is a molecule. In that A and B, this is AB is substrate, organic molecule. This will be clear separate. If A and B, atoms of A and B, if any one is more electronegative, either A or B, if B is more electronegative than A, then the shared pair of electron shift towards B, then it forms A plus B minus, right? Why this separation will take place? Because out of AB molecule, B atom is more electronegative than A. Electronegative tendency of dragging the pair of electron towards themselves. If B is more electronegative than A, so it drags the pair of electron towards B, then B will forms a negative charge, B minus, and A is positive charge, A plus. Positively charged ions are called cations, negatively charged ions we call as anion. Okay, so which forms anion and cation. Heterolytic or heterolysis results in the formation of cation and anion. This is because unequal cleavage. Not only this, if it is reverse, out of AB and A is more electronegative. If A is more electronegative, then it is A minus and B plus, right? If B is more electronegative, electron shift towards B, so cloud electron density on B increases, so B is negative, means anion, and A is cation. Out of AB, okay, out of this A and B, if we consider A is more electronegative, if A is more electronegative than B, then resultant means reaction mechanism will be forming A minus and B plus. Okay, so A minus now is anion, negatively charged ion, and B plus is cation, positively charged ion. This is how heterolytic process heterolysis will take place, means due to differ in their electronegativity in the molecule, that leads to the creation of or the formation of anion and cation. This will happen because of heterolytic or heterolysis, unequal cleavage. Okay, heterolysis is the cleavage or the bond break in such a way that the shared pair of electrons are carried away by one of the substrate atom. Okay, and it will be separated. If any atom are separated, will be forming whether anion and cation. So this is how what I said, an A, B. So AB, when B is more electronegative, which will be forming the negative charge. Okay, are you? I think you are noticing here. B forms a negative, shared pair of electrons shift towards B minus. So B consists of a lone pair of electron towards on it, not a lone pair of electrons on it. So electron rich negative charge. Okay, and out of AB, A is more electronegative, then A will be a negative charge, will be having the pair of electron, means two electrons are shifted. A and this is B. So one electron from A, another electron from B. These two shares with each other will be forming covalent bond. If A is more electronegative, A can able to drag the pair of electron towards nearby A itself, and on the B electron density is less, hence which will be getting positive charge B and A will be getting negative charge. Okay, this is how heterolytic cleavage will take place in organic molecule. Okay, so this is heterolytic. Similarly, homolytic. In the case of homolytic, how it forms? Okay, in the case of homolytic, we notice that cleavage will be takes place, separation will be takes place equally. In the case of equally, we can notice that A and B. If AB is a molecule, will be having the one electron from A, another electron from B. With a cleavage will take place equally, will be forming A dot plus B dot. A dot plus B dot we call as radical. We call as radical. This is homolysis. Homolysis, there will be no cleavage of bond, is nothing but equal cleavage of electron. Equal cleavage leads to the formation of radical. Okay, radical. Each atom will be consistent electron with each other. Okay, so A will be having an electron, B is also will be having an electron. So which leads to the formation of radical, that is homolysis. Okay, we'll study heterolysis first. Okay, heterolytic reactions, how the heterolytic reactions will take place. I think heterolysis, you are clear about the heterolysis and homolysis. Hetero means differ, unequal cleavage. Homo means equal cleavage. Cleavage will be equal. Cleavage is equal, then it is called homolysis. In homolysis, A and B are same electronegative. Electronegativity difference is zero. So then what happens if there is no electronegativity difference and can have the electron on each of the atom of A and B? This leads to, if cleaves also, leads to the formation of radical. Okay, so we'll see what will happen with the heterolysis, means the cleavage, unequal cleavage of the atoms. Unequal cleavage of atoms leads to the formation of anion and cation. Clear? Anion and cation. So we used a word of attacking reagent. Okay, we use a word of attacking reagent in presence of attacking reagent, whether and either a E plus or a Nu plus. E plus electrophile, Nu not Nu plus, Nu minus, that is nucleophile. Okay, electrophile and nucleophile, we'll see the difference. Electrophiles are electron deficient group. Electron deficient group, and nucleophiles are electron rich group. Okay, there will be difference between electrophile and nucleophile. Electrophiles are electron deficient and nucleophiles are electron rich. Due to this type of attacking reagent, then the reaction will take place. Okay, this unequal cleavage leads to the formation of carbon positive charge and carbon negative charge on the carbon, because organic chemistry deals with the study of carbon compounds. So carbon forms a positive charge ion, carbon can able to form negative charge ion. Positively charged ion, carbon cation, also we call as carbocation, carbocation, and carbon negative charge is also we call as carbene ion, carbon anion, carbene ion. Okay, carbocation and carboanion. Carbon will be getting positive charge as well as carbon will be getting negative charge. So we'll see in detail about carbocation and carboanion, carbocation and anion. So first one, carbocation. So carbocation, how it will be formed? This is formed because of the heterolysis. During the heterolysis, unequal cleavage, heterolysis or unequal cleavage of the bond will break unequally when the substituent attack to the carbon chain. Substituent attack to the carbon chain is more electronegative than carbon. If the attacking reagent has more electronegative than carbon, then what happens? It drags a pair of electron towards themselves. If C is a carbon and attacking reagent, I'll write AR. If attacking reagent is more electronegative means tendency, having a capacity to drag the pair of electron towards himself is more. If it drags a pair of electron towards it, then carbon obviously will be getting the deficient of electron. Deficient of electron, which forms positive charge on the carbon, is nothing but carbon cation, is also known as carbocation. Okay, what is carbocation? A carbocation is a charged species in which carbon carries positive charge. Carbon carries positive charge here. So carbon, why carbon carries positive charge? Because attacking reagent, what it will be means attacking reagent or the substance which attacking reagent can drag it. Otherwise, any group attached to this, example, if carbon consisting the halogens, okay, if this carbon consisting and halogen group 17 elements. Group 17 elements are more electronegative than carbon. So what happened? Electron shifts to more concentrated towards X. X will be getting the negative charge and C will be getting positive charge. If carbon attached to a more electronegative, then unequal cleavage will take place with the formation of C plus and X minus. Okay, C plus is carbocation and X minus is halide ion. Halide ion, more electronegative, so it obviously drags a pair of electron towards itself. Are you getting? So how carbocation is formed? Carbocation is formed during the heterolysis when the substituent attached to the carbon chain, any substituent attached to the carbon chain which is more electronegative than carbon. Okay, if any group attached to the carbon, if it is more electronegative, X is more electronegative than carbon, group 17 element drag the pair of electron towards themselves, so carbon will be forming the positive charge, and this is called carbocation. Are you getting? Carbocation. So we'll see an example to this carbocation, how the chain is attached. An example, CH3Br, methyl bromide. In the case of methyl bromide, so carbon will be consisting the 3 of hydrogen, CH3. Okay, and one of the hydrogen replaced by Br, and Br bromide belongs to group 17, which group 17 elements are more electronegative than carbon. Okay, then what it forms? Yes, sir. What it happens? CH3 and Br. Br is minus halogen, no, more electronegative, which will be drags a pair of electron towards on the bromine. On the bromine. So carbon will be getting positive charge, which forms CH3 plus and Br minus. This also we call as methyl carbocation, because the 3 of hydrogen here and another is positive charge, another is positive charge, so which is called methyl carbocation. Carbon will be fostering positive charge and the 3 group at hydrogens are attached. Carbon number 1 methyl, okay, less than 1 hydrogen is methyl carbocation. This also be called as carbonium ion. Carbonium ion is carbocation. Methyl carbocation is called carbonium ion. Okay, CH3 plus carbon will be forming positive charge. Okay, this is carbon cation. This carbon cation, how we are getting this carbon cation divided into 3 types. Okay, this carbocation or carbocation. So how this cations, carbocation divided into 3 types. So out of this, first one is alkyl carbocation. Alkyl carbocation. Second one is allyl carbocation. ALLYL, allyl carbocation. And next is benzyl carbocation. Benzyl carbocation. I said alkyl carbon, allyl carbon, and aryl carbon or benzyl carbon. I said in the beginning. Okay, so carbon single bond, that is an sp3 hybridization, that is we call as alkyl carbon. Alkyl carbon, carbon and hydrogen group, any carbon hydrogen group we call as an aliphatic carbons. Okay, aliphatic carbon, carbon hydrogen. Okay, that is in carbon sp3 hybridized, that is in carbon single bond. Carbon carbon double bond, that is sp2 hybridized carbon. sp2 hybridized carbon we call as allyl carbon. Allyl carbon, I'm not saying carbocation, allyl carbon. Next, benzyl, any group, benzene group attaches to any other group, then it is called aryl. Then it is called aryl, ARYL. If it attaches to any CH2 group, then it is called benzyl. Benzene attached to any CH2 group, okay, then it is called benzyl. This is benzene ring. And for this, attached to CH2 group, any CH2 group, then it is called benzyl. Okay, so I think you are familiar with the word of alkyl, allyl, and benzyl. Okay, alkyl, allyl, benzyl, sp3 carbon, sp2 carbon, and benzene with CH2 group. Okay, now this carbocation divided into 3 types: allyl carbocation, alkyl carbocation, allyl carbocation, and benzyl carbocation. Okay, so we'll see the difference between alkyl, allyl, and we know the difference between alkyl, allyl, and benzyl. Okay, so in this further alkyl allyl in benzyl, alkyl carbocation divided into 1 degree carbocation, 2 degree carbocation, and 3 degree carbocation. We know that the degree means which is nothing but if CH3 group in the case of methyl, so carbon will be having the CH3, 3 of hydrogen, it attaches to carbon attached to any other carbon or nothing, then it is called 1 degree. CH3 or CH3CH2, this is also, okay, CH3 or CH3CH2, this is also we call as 1 degree. 2 degree means will attaches to the other two carbon, example CH3, CH. CH3. This is carbon attaches to two other carbon. Then it is called 2 degree. We'll be having the positive charge. So CH plus. Similarly, 3 degree. 3 different group it attaches to CH3, C, CH3, CH3 in all the three sides. Methyl is CH3 and methyl CH3 will be forming positive charge. This is 3 degree. Okay, so 3 degree, 1 degree alkyl, 2 degree alkyl carbocation, and 3 degree alkyl carbocation. In that, the stability increases from the primary 1 degree to 3 degree, primary to tertiary, increasing order. Okay, so this from stability in towards stability of alkyl carbocation increases from the primary to tertiary. Tertiary will be the most stable. Okay. In the case of the allyl, this will be what is the effect? How this will be changed? Electron migration will be studied later. That is from the inductive effect and as well as the hyperconjugation. This how will be stability can able to explain. Okay. Next in alkyl. So this is in alkyl. Next in allyl also. Allyl carbocation again further divided into 1 degree, 2 degree, and 3 degree. Allyl. Okay, allyl carbocation. So I'll write in the next sheet, the next page. Okay, so here I'll write allyl carbocation divided into 3 types. Okay, alkyl carbocation, allyl carbocation, and benzyl carbocation. So 1 degree carbocation further divided into 2 degree carbocation and 3 degree carbocation. In allyl also 1 degree carbocation, 2 degree carbocation, 3 degree carbocation. In benzyl also 1 degree carbocation, 2 degree carbocation, and 3 degree carbocation. So this is how the effect will take place here. The carbocation stability increases from 1 degree to 3 degree. So increasing order will say that CH3. Okay. So here from 1 degree to 3 degree tertiary, which will be increasing order. Stability, we can say is at 1 degree, 2 degree, 3 degree cations. Okay. So in the case of alkyl and aryl and benzyl, in alkyl carbocation, 3 degree alkyl carbocation is most stable. Okay. So in the case of cations, if we use a word of the cation, positively charged ion. So we didn't discuss the structure. So still we are in carbocation. I'm explaining how the order means either primary, secondary, and tertiary. Because we are familiar with the 1 degree, 2 degree, and 3 degree. How the carbon attaches to same any other carbon or carbon with hydrogen. If two of the carbon attaches to carbon, second degree. If carbon attaches to 3, then it is called tertiary. So in allyl also, in allyl carbocation, the carbon carrying positive charge attached to sp2 hybridized. Here, carbon charge carries to sp3 hybridized. Positive charged carbon will be having an sp3 hybridized is alkyl. Positively charged carbon will be attached to sp2 carbon, means will be having a positive charge. then it is called the carbon allyl carbocation or allyl carbocation. Okay, this also explained with the help of resonance effect. So we'll study later. Here I said inductive effect. This can be explained with the help of inductive, how it will be moved. Delocalization of electron can able to explain inductive effect. Here I'll be saying the resonance effect. I'll explain later what is the resonance effect. So the example, if you consider the example in allyl group, okay, allyl carbon example CH2. CH2 attaches to some other carbon with hydrogen double bond CH2. If this carbon having a positive charge, this carbon having positive, neither the next carbon will be in under carbon-carbon double bond, which is an sp2 hybridized. Carbon will be an sp2 hybridized. Then it is called, this carbon is called allyl carbocation or allylic carbocation. In this, tertiary carbocation is most stable than the primary. Tertiary is the most stable carbocation than primary. So how it will be tertiary? This can also be written as this allylic carbocation attaches to the two other group. If it is tertiary, three other group. So I'll write in tertiary here. Carbon CH2 for this double bond CH and single bond C. This will be having positive charge, and this is some other group R group attaches to this. So will be, this is positive charge. This attaches to a carbon is in double bond. Then it is tertiary allyl carbocation. This is tertiary allyl carbocation. Okay, this will be most stable than secondary than primary allyl carbocation. Okay, next, benzyl carbocation. I said that benzyl. So benzene, a benzyl carbocation is a charged species. Okay, positively charged, in which carbon carrying positive charge attached to sp2 hybridized. sp2 hybridized, we know that double bond. So by delocalized electron in aromatic ring attaches to a carbon will be having sp2. So if it is a benzene ring, will attaches to CH2 group. Okay, CH2 group, CH and some other group, and hydrogen or R, example CHR. Then carbon will be having positive charge. This is called benzyl carbocation. Is called benzyl carbon. This is called as benzyl carbon. Okay, so CH2R is called benzyl carbon. In this also divided into 1 degree, 2 degree, and 3 degree. I'll erase completely. Okay. In the case of the benzyl, so I'll write benzene. Okay, will be having an alternate double bond. To this, carbon will be attached, and I said the CHR group, if attaches to two other group, here carbon, here R group, here R group, then it will be tertiary carbon, tertiary benzylic cation. This is tertiary 3 degree, tertiary benzylic cation. Okay, so this one is the most stable. This one is the most stable than secondary, than 2 degree, than primary 1 degree. So for the secondary, I will write that will be CH. Same benzene ring. For this benzene ring, carbon will be consist of this carbon, one hydrogen and other group. So this will be sp2 carbon will be having the two other group attaches to this. This is secondary 2 degree. And primary, same CH2. Benzyl group for this carbon CH2 will be having the positive charge. This is 1 degree. This is 1 degree. This is 2 degree. And this is 3 degree. 3 degree is the most stable carbocation. 3 degree greater than 2 degree greater than primary. So out of all, now all the three carbocation, so all the three carbocation means allyl, alkyl, and benzyl. So order, you need to remember the order. So 1 degree benzyl in the terms of the stability, how we can say so. So stability of primary, secondary, and tertiary. 1 degree benzyl, 1 degree benzyl carbocation is greater than 1 degree allyl, allyl carbocation greater than 1 degree alkyl carbocation. Okay, so in terms of the tertiary, 3 degree tertiary carbocation, 3 degree alkyl alkyl carbocation is greater than 1 degree benzyl, benzyl benzyl carbocation. It is just 1 degree benzyl carbocation is greater than 1 degree allyl carbocation. 1 degree allyl carbocation is almost same as 2 degree alkyl alkyl carbocation, alkyl carbocation. So we'll be discussing later. So methyl and vinyl, arenium ion, and etc. So this are this you need to remember the stability. The stability you need to remember. 1 degree benzyl is benzyl carbocation greater than 1 degree allyl carbocation greater than 1 degree alkyl carbocation. Next, 3 degree alkyl carbocation greater than 1 degree benzyl carbocation greater than 1 degree allyl carbocation. 1 degree allyl carbocation is almost same as 2 degree alkyl carbocation. Okay, so this is about the carbocation. So when we didn't see structure, how it will be, how many number of electrons are there in carbocation, what is its hybridization, and for the electron, what we call for that. Okay, so carbon will be having positive charge, we call as carbocation, right? So we'll see structure of carbocation. Carbocation will be having TBP structure, trigonal planar shape or trigonal planar structure. Okay, trigonal planar structure. We know that sp2 hybridization. sp2 hybridization is an example of AB3 type of molecule. sp2, 2 plus 1 is 3. Okay, so AB3 type of molecule. In the case of the AB3 type of molecule, can able to have the trigonal planar structure, trigonal planar structure. So S and P, total how many? The 3 of the hybrid orbital. So we can notice here an sp2 hybridization in carbocation, which have a trigonal planar structure, trigonal planar shape with a positively charged carbon being an sp2 hybridized. In this case, pz orbital to pz orbital, which is perpendicular to the plane of sp2 hybrid orbital. In carbocation, the positively charged carbocation consists 6 electrons, hence it is called sextet of electron that behaves as electrophile. Electrophile. So attacking reagent. We'll be studying attacking reagent of electrophile and nucleophile. Electrophile forms due to carbocation. How carbocation will forms? Attack the group, any group attaches to a carbon, that attached group is more electronegative, then electron shift towards halogen, means more electronegative group than carbon, then carbon will be forming positive charge, that is carbocation act as electrophile. Positively charged electrophiles are positively charged ions, right? So because the electron deficient, out of px, py, and pz, px and py, 2p are involving, one electron will be removed from this. This will be perpendicular. All the lobes are the perpendicular with each other. Always those are the perpendicular with each other, px, py, and pz. If you consider any orbital, all are perpendicular. So 2pz is perpendicular to the plane of this sp2 hybrid orbital. If this is the plane of orbital and this is the plane, here you can notice, no, this is the plane. Here is the hybridization. To this hybridization, this will be perpendicular. This p orbital, pz orbital is perpendicular. Rest of the two orbitals are in plane. So this is in plane, here in plane, and here plane. So what it will be? This is perpendicular. This is a plane and this will be in perpendicular to PZ. And we know that in sp2 hybridization, the bond angle is 120 degree and PZ is perpendicular and these are electron deficient. 6 electrons are carbon, hence it will be caused as the sextet of electron and they behaves as electrophile. Okay, so carbocation act as electrophile, you need to remember. Okay, similarly, in the case of if the reverse substituent group will be less electronegative than carbon. If any attached group, okay, so in this carbocation, I said based on that in generally how the carbocation, primary carbocation is greater than secondary carbocation is greater than tertiary carbocation. You need to remember generally how we'll say is the general stability of cation. General stability of cation, this we can able to explain on the basis of inductive effect. Okay, so I'll tell you what is inductive effect later. Inductive effect, so primary carbocation CH3 plus is greater than CH3. So stability increases CH3 greater than CH3 CH2. Okay, in generally CH3 means secondary. Instead of that, I can write now primary, secondary, tertiary. 1 degree carbocation greater than 2 degree carbocation greater than 3 degree carbocation. This is in general. In general, stability of carbocation. Primary is greater than secondary is greater than tertiary. In general, this can be explained with the help of inductive effect. Okay, you need to remember. If the reverse, if attached group is less electronegative than carbon, what happened? So carbon, on the carbon, there will be a pair of electron. So which act as example C, okay, and the attacking reagent, some reagent R. Okay, if the attacking reagent is less electronegative than carbon, carbon can drag the pair of electron towards themselves, then carbon will be having negative charge. If carbon will be having negative charge, the other group will be having positive charge. Then carbon act as an anion. Negatively charged ion is called carbene ion or called carbon anion. Carbene ion or carbon anion. See, carbon anion are formed by or during the heterolysis when the substituent attached to carbon and the carbon chain is less electronegative. Carbon chain or carbon itself is less electronegative than carbon, then carbon anion charged species in which carbon carries a negative charge. Substituent group is less electronegative than carbon, then carbon will be getting the partial, means complete negative charge. Due to that, the anion will be forming, that is called carbon anion. So in carbon anion, how will be the structure of carbon anion? Okay, so in the carbon, I said earlier, I said that is about carbon anion, carbon cation and carbon anion. In the case of carbon anion, example, okay, so exactly opposite to the cation. We said the cation tertiary is more stable than primary. In anion, the primary is more stable than tertiary, right? In the case of example, substituent group, if carbon attaches a substituent group, okay, so substituent group again the same as it is carbon anion, allyl, aryl, benzyl, the carbon anion, the same, everything is same, but only you need to understand some other group. So instead of X, we'll use some attacking reagent. No, if attacking reagent is less electronegative, what happen? Carbon will be getting the negative charge. So carbon group or carbon will be having negative charge, then it is carbon anion. Carbon anion. This again further divided into alkyl carbene ion, alkyl carbene ion, aryl or allyl carbene anion, and benzyl carbene ion. This is also written. But stability of carbon reverse to that. So that is in generally carbon anion 1 degree carbon anion is greater than 2 degree carbon ion, greater than 3 degree carbon ion. In the case of carbocation, it is reverse. 3 degree is more stable, no? In the tertiary carbocation is more stable than primary, secondary than primary. That is reverse. So stability increases from primary to secondary, secondary to tertiary. Reverse carbocation. In carbocation, 3 degree is greater than 2 degree is greater than 1 degree, right? Now, so we'll see this the structure of the carbene ion. Example and structure. See CH3Z, methyl and some other group attached. Group is the electron donating group, not electron withdrawing group, electron donating. Which are electron, why we call as an electron withdrawing and electron donating group? If electron withdrawing group, if electron takes from the carbon, then carbon form positive charge. Electron donating group, this group supporting group itself, attached group is less electronegative. So it's not ready to take electron. Then carbon will be having negative charge, will be forming the carbon ion. So carbon negative charge is called methyl carbon ion with the formation of positive charge. Okay. So we'll see in the next the structure of carbon ion. So carbon ion is a pyramidal shape. Okay, we'll be having an extra electron, additional electron. Normally, carbon should have an 6 electron. The deficient of an electron, to stability. 2 electrons are required to form stable. So pair of electrons shift towards on 8. Then we're having an 8 electron. Carbon ion having a pyramidal shape with a negatively charged carbon, being an sp3 hybridized carbon single bond, no? sp3 hybridized, and it is an extra pair of electron, 2 electron pair of electron extra. Okay, extra pair of electron. So which negatively charged, consisting in 8 electrons, then behaves as nucleophile electron rich group. Nucleophile are called electron rich group. So methyl carbene ion act as a nucleophile because extra electron will be present on it. So the charged carbon contain 8 electron and they behaves as nucleophile. The bond angle is less than the normal tetrahedral. So 109.5 due to repulsion between the lone pair and bond pair. Between lone pair and bond pair, there will be repulsion. Due to that TD structure, distorted tetrahedral structure, even though we'll be having an sp3 hybridization. Okay, so pyramidal in shape will be having in a carbon negative charge. Due to the presence of lone pair of electron, there will be repulsion. We call it steric hindrance, repulsion force between them. So we'll be getting the distorted structure. Okay, so the negatively charged ion, carbene ion. Okay, this carbon ion also we divided into 3 types: primary, secondary, tertiary of alkyl, allyl, and aryl. In the carbon, generally, we need to remember this can able to explain with the help of inductive effect. CH3 minus carbon ion, primary carbon ion is stable than CH3, CH2. The secondary carbon ion is greater than CH3, CH3. Tertiary carbon ion, okay, primary, secondary. This is primary, 1 degree, okay, CH2. Then secondary is greater than tertiary, 3 degree of all the methyl group and is a negative charge. Here CH3, CH3 and CH3. This is tertiary, 3 degree, 2 degree, 1 degree and 1 degree. So that is in the order. So primary 1 degree carbene ion is greater than 2 degree carbon ion, greater than 3 degree carbon ion, reverse to that of carbocation. Okay, so this is the structure and how it will be the carbocation and carbon anion, carbene ion and carbocation. Okay, so in this session we discussed about this one, stability. Okay, so we said that homolysis. This is what we discussed about heterolysis. In the case of homolysis, homo equal cleavage. In homolytic cleavage, the bond break in such a way that the separated atom carry 1 electron each during the homolytic cleavage. This movement of a single electron takes place instead of electron pair. Instead of electron pair, single electron will be carries. Single electron moment represented as half-headed arrow. Half-headed arrow. Fishhook. This is also be called as fishhook. So in earlier reaction, we used to represent like this. Cleavage will be takes place AB, cleavage AB to forms an A plus B minus. We said that the bond will break. A and B bond will break, will be representing like this. Is nothing but unequal cleavage. If it is equal cleavage, if it is equal cleavage, AB bond, we need to represent with fishhook, half arrow, half-headed arrow. So in this only one-headed, because if half cleavage equally, that will cleave. So half-headed arrow or fishhook or curved arrow. So homolytic cleavage result in the formation of radicals, free radicals. Free radicals are a neutral species which contains an unpaired electron. Neutral species which consists an unpaired electron. Okay, so homolytic cleavage, equal cleavage, equally they get separated. Okay, you can notice this A B cleavage. This is in fishhook, no, and A and B. This one A dot and B dot will be forming the free radicals. Okay, so that is homolysis. In this homolytic cleavage, so free radicals are also divided into alkyl free radical, allyl free radical, and benzyl free radical. Okay, so this will be used divided into three types. Okay, in alkyl free radical, again this alkyl free radical can able to explain the hyperconjugation. I'll tell you the later. That is a displacement reaction. Okay, hyperconjugation. So in this also tertiary 3-degree free radicals is greater than 2-degree free radical greater than primary free radical. That is the order, stability of the order. In general, 3-degree free radical is more stable than 2-degree than the primary. In this, always alkyl, allyl, and benzyl. sp3 alkyl, sp3 attached to sp3 carbon, sp2 carbon, and the benzene attaches to and carbon attached to an sp3 carbon, sp2 carbon, sp2 allyl and benzyl, sp3 carbon, that is alkyl free radical. Okay, so primary, secondary, tertiary in that 3-degree greater than 2-degree greater than primary. Okay, free radical, structure of free radical. So the structure of free radical will be having the trigonal planar shape. There's also the trigonal planar shape. Okay, how it will be carbon. Okay, carbon will be having this carbon and carbon. This in the case of carbon will write any this side or this side. Okay, again which will be in perpendicular. P orbital will be in perpendicular. So if we consider the three, I'll write like this: carbon with one side here and here carbon here attached to other group. So that is in the plane, that is 120-degree. And this p orbital is perpendicular. The slope is perpendicular, which will be consist of one unpaired electron. This is unpaired electron, and this is p orbital, and which is undergoes an sp2 hybridization. sp2 hybridization, which will be consist unpaired electron will be consist. So unpaired radical, which because of the one unpaired electron, which have 7 electrons, 6 plus 1 unpaired electron, this will be consist 7 electrons. Okay, that is under sp2 hybridization. This is homolysis. Homolysis, equal cleavage, homolysis. Okay, so now we come to know that electron rich and electron deficient. Electron rich and electron deficient we call as electrophile and nucleophile, right? Electron deficient and electron rich. So we'll see the difference between the electrophile and nucleophile. Okay, so what is electrophile and what is nucleophile? Examples for the electrophile and nucleophile. Okay, first one, we'll notice the first one, attacking reagent, electrophile. Electrophile are E plus, nucleophile are Nu. Yes. In the case of electrophile, they are electron deficient group. Electron required. Electron required deficient. They have a tendency to accept the pair of electron to other molecules because the deficiency, the tendency to accept from the other molecule. Electrophiles may be neutral or positive charge. Electrophiles are positive or in some cases the neutral also. And the neutral electrophiles and the electrophiles having positive charge, we have an example. And these will be act as behaves as Lewis acids. This act as Lewis acids. Lewis acids electron don't pair acceptor, act as electron pair acceptor. These electrophiles are generally heterolysis of covalent bond, unequal cleavage. Due to that only will be forming positive and negative charge. And these are the examples for the neutral electrophile and charged electrophile. Neutral electrophiles like BF3, BCl3, AlCl3, BCl2, FeCl3, SO3 are etc. These are neutral electrophiles and doesn't have any charge but tendency to accept because less than 8 electronic configuration. Okay. In the case of charged electrophiles, will behave as ions. Okay, this will be having positive charge, Cl plus, Br plus, I plus, Cl plus, whether it is formed Cl plus or S, can able to form positive charge, chloride ion, bromide ion. There will be possibility with the formation of chloride, bromide ion, NO2 plus, NO plus, H plus, H3O plus, hydronium ion, NH4 plus, simply an R plus alkyl group. Okay, this will be having positive charge. Electrophiles are generated by electrolysis of covalent bond. And the transition metal ion like Fe3 plus, Fe2 plus, Ag plus, Hg plus, C2 plus, these are all positive charge. As again, attacking reagent, act as attacking reagent of electrophile. Okay, so electrophiles are electron deficient. Remember, what are electrophiles? Give an example. Electrophiles are electron deficient group. Okay, they're ready to accept the electron or electron pair, ready to accept the electron pair from other molecule. Okay, so example BF3 or BCl3 or NO2 plus or H3O plus or Cl plus or etc. Okay, opposite to this is nucleophile. Nucleophile are electron rich group. Nucleophiles are electron rich group, and these are tendency to donate a pair of electron. They are tendency to accept electron deficient group, electrophile. Okay, nucleophile, these are electron rich species, extra additional electron. They have a tendency to donate a pair of electron. They attack the center of the minimum electron density in a chemical reaction. So they attack the center of, example, if here carbon will be having positive charge and nucleophile attacks to where the electron deficient center, electron minimum electron density. Here the more electron density here in this one, and this one is more electron density. And the middle carbon will be having less electron density. This group attacks on this carbon because the minimum electron density. And this will be act as Lewis basis, electron rich no, lone pair donor, the act as lone pair donor, and these are separated by, these are also formed by the heterolysis of covalent bond. Unequal cleavage of the covalent bond leads to the formation of nucleophile. Examples, this may be they are consisting the negative charge or maybe a neutral species also. Negative charge F minus Cl minus right side of the elements, I minus OH minus Cl minus RCO minus R NH2 minus R etc. Neutral like NH3 because it will be consisting pair of electron, no? R3N nitrogen compound. H2O, H2 oxygen will be having pair of electron, or OH alcohol oxygen will be having pair of electron, NH2, okay, NH2, okay, this will be having the pair of electron. So can able to donate a pair of electron, act as nucleophile. So the difference, you need to know the difference between electrophile and nucleophile. Electrophiles are electron deficient and nucleophiles are electron rich. the difference between electrophile and nucleophile. This is deficient, no, and this is rich of electron. This both will be formed by the heterolytic cleavage, and electrophiles act as Lewis acid. Lewis acid. Nucleophiles are Lewis bases. Okay, this will be having positive charge or neutral, and this nucleophile will be having negative charge or neutral. Okay, and this will be tendency to donate of electron. This will be tendency to accept the electron. So where the group attacked, electrophile attacks to maximum electron density. Carbon will be having negative charge. Any carbon will be having negative charge. There the electrophile attack, and nucleophile attacks to minimum electron cloud, minimum electron density. Right, will be attacks. There is a difference between electrophile and nucleophile. Are you getting? So in this session, we learn about reaction mechanism, carbocation, carbon anion, their hybridization, homolysis, heterolysis. Okay, and attacking reagent of electrophile and nucleophile. Okay, in the next session, we'll continue with electron displacement reactions. Is nothing but effects of electro-inductive effect, electromeric effect, ice resonance effect, and hyperconjugation or Nathan-Baker rule. Okay, so we'll continue in the next class. Thank you.